Amandeep sir.
Good morning, everyone.
Good morning, sir. Welcome to the webinar.
Thank you. Yeah, please let me know if I am audible.
Am I audible?
Yes, you are audible.
Yes, you are audible. Yeah.
Okay.
Good morning, Amandeep sir.
Good morning, sir.
Yeah, good morning.
Hello and good morning, everyone. I hope you all are doing well. I am Harsh Patore. Welcome you all on behalf of Electronics and Telecommunication Department, IETE-SF of Excelsior Education Society's KC College of Engineering and Management Studies and Research. I feel privileged to welcome you all here. I heartily welcome our Managing Director, Dr. Sai Kiran Khanna sir, in his absence. Now, I would like to welcome our Honorable Principal Sir, Dr. Vilas Nitnore Sir, Vice Principal and IQS Head, Dr. Arundhati Chakravarti Ma'am, Head of EXTC Department, Dr. Rajiv Iyer Sir, Professor in EXTC, Exam Cell in Charge, IETSF Convener, Dr. Baban Yurinde Sir, IETSF Faculty Coordinator, Professor Purnima Vadak Ma'am. Last but not the least, our revered professors, without whom we students are not complete. They always support and guide us in many unimaginable ways. And of course, our starling students and the participants. I would like to thank all the participants from various colleges, institutes, and industries who have registered today for this webinar. Thank you so much for overwhelming response for the webinar on modeling of optical networks using Optiwave software. It's my pleasure to inform you all that we have 300 plus registrations from all over India. Now, without any further ado, let's begin the event. But prior to that, it is a matter of great pleasure and honor for me to invite someone who's known among all of us for his wisdom and his knowledge. Sir has always encouraged students to give their best. Now, I request our Honorable Principal Sir to address the event and to give his valuable inputs to everyone present here.
Thanks, Kunal. Good morning, everyone.
Good morning.
First of all, I welcome Mr. Amandeep Singh,
Thank you, sir.
who is Product Manager from HR Universal System Inclusive. Sir will deliver a national webinar on modeling of optical networks using Optiwave software. I convey my sincerest thanks to Amandeep ji for accepting our invitation and giving permission to guide the students of my institute as well as to the student of other institute across India. I convey my sincerest thanks to Amandeep ji. I also congratulate Department of Electronics and Telecommunication who took the lead to organize this webinar. Credit goes to Dr. Rinde sir and his team member. Kunal just now informed that around 375 registration has been received so far. It indicates the popularity of this webinar. So dear friends, optical networks gaining popularity. There are plenty of reasons. We are all aware. This is not the topic to be discussed at this moment of time because this is the expert area of Amandeep ji. But as I could summarize some of the typical benefits of optical networks, it offers greater bandwidth as compared to the bandwidth offered by metal cables. Since bandwidth is higher, so naturally speed is greater. I also came to know it offers longer transmission distance. Flexibility is very good. Latency is improved. And the most important part of this optical network, it offers greater security. So dear friends, it's a great honor for all of us that on this hot topic, emerging technology, Mr. Amandeep ji will be telling you how to do the modeling of optical networks using Optiwave software. So it's a webinar. Probably webinar may just help you to understand the topic, but for modeling, I feel that it must be a training program of at least a week. Then and only then probably participants will be able to, understand the methods of modeling, isn't it? So I request maybe Amandeep ji, he should find some time in the future as per his convenience and accept this training program so that hands-on sessions on this Optiwave software could be conducted and the participants will get the immense benefit out of this workshop. So with this, I convey my best wishes to all the participants and I wish participants should take each and every information provided by Amandeep ji very seriously and see how best they can do, particularly their career in the field of optical, because quantum computing is the next technology which is being discussed these days, and it is said that this quantum computing will replace maybe the conventional computers, isn't it? And so all the information and computing will happen in future with the help of quantum computing powered by optical. So optical will have a future. So I just wish you should take it very seriously and see how you can make your career in this particular field. With this, I conclude. Thanks, organizers, for giving me an opportunity to share my thoughts. Over to Kunal. Thank you.
Thank you, sir, for your kind words. Now, I would like to request the HOD of ESTC department, Dr. Rajiv sir, to share few words on today's webinar. Over to you, sir.
Uh, Thank you, Harsh. So it's a well-timed webinar, I would say, on optical networks since we are on the onset of 5G, and as far as my understanding goes, this happens to be the backend. And additionally, we may not be in a position to handle the actual hardware because of its cost, and hence we will be using this particular software which is for modeling. And through this software we can actually understand that what is going on in the hardware. This is my understanding of the topic. I may be wrong. On behalf of the Department of Electronics and Telecommunication, I welcome Mr. Amandeep Singh, uh, and wish all the students should get maximum benefit out of this webinar, and specifically final year students, as it is part of their curriculum, and this is something advanced which is being told as on today. So, on behalf of IETE-SF, I congratulate Rinde sir and Punya ma'am for taking it ahead. Thank you.
Thank you so much, sir. I strongly assure you that this program will be a source of great inspiration, insight for all of us. Now, I would request IETE-SF convener Dr. Baban Yurinde sir to share a few words on today's webinar.
Yes, Harshal, thank you very much, and welcome to all respected on the online mode. First of all, I had to thanks to Amandeep Singh he has accepted our invitation for today's program, and today we have the webinar on the modeling of optical networks using Optiwave software. Here the first motto is to actually this we have first of all organized for the students for the third year and final year to make the mini project for their curriculum for the additional content beyond the syllabus. Every year we are making that the mini project for the final year students under the optical communication and network subject. This is a new subject for this academic year R19. It is a combination of computer communication and networking. This is two part that is combined with that, and for that the definitely we have associated with the Amandeep Singh. Thanks to him also for my PhD from till date we have the contacts to each other, and we have to communicate for the webinar also. I also given the speech as they invited me to give the speech on this optical network topic on various webinars and as a offline mode and the webinar also. Therefore, I have to thanks to the Amandeep also. Previously, he has given the chance to me to speak to programs. And today that we have the various that now we actually from various states that total the members are participants are joined for this today's program, and that is a very important for the achievement for this program is today that 375 students are joined for this program. And students as well as faculty members, and just I got the message from the IIT Bombay also. The some participants of the MTech students they have joined this program. Therefore, that is the achievement, and all over India actually that we have the participants. We have got the response previously. We have started that actually Amandeep has we have to give the credit to the Amandeep also. He has motivated to me to organize this event for the national level webinar. And he has messaged me also called continuously. We are working to each other. Since sir, you have other participants also, faculty also wants to join this program. Therefore, I accept his actually the request, and we have changed this to the webinar at the national level. Therefore, I had to thanks to him also actually, and our ISEP team, including the Purnima Vadak, as she has took the lead, and she has organized this event with the help of this our students council ISEP, Avinash Rajak, and the Vaishali Chaudhary and Kunal also. He and these members are actually conducting these types of events in offline mode, online mode, organize the various workshop technical programs, and that will be the give the motivation to other students also. They get the knowledge also with the help of this IETE-SF forum. Why today's program we have actually choose that optical networking is the important is a topic and important field that is the backbone of the network. We are talking about the 5G now that 5G are already launched, and definitely that comes in the so optical networking that will be the important role that will be play. Huge bandwidth is available, numerous bandwidth we are talking about that, very less noise and every that telecommunication that we have the backbone of the network is the optical, and definitely in previous in future that comes the photonics networks, and therefore this communication that uses the signals encoded in in light to transmit information in various types of telecommunication networks, and these includes limited range local area network and wide area networks. That will be the important, and definitely across metropolitan and regional areas, as well as the long distance national, international, and ocean networks that we have to put the fiber underground sea, and therefore we have to connect the country to country with the help of the single mode fiber, and that is there's a main backbone of the we are talking about the backbone of the network with the help of this optical networking. It is actually the form of the optical communication that relies to an optical amplifiers also, lasers also as a source, laser, LEDs. Then wavelength division multiplexing to transmit larger quantity. At the receiver side, we have the detector, photo detectors, that is a APD and pin photodiode, and the generally these are across the fiber optic cables, and because of it capable of achieving the extremely high bandwidth, it is the enabling technology for the internet and telecommunication networks that transmit the vast majority for all human and machine and to machine information. Therefore, this definitely that the important networks that with the optical networks and how we have to do the modeling, that is also important. Today, the Amandeep Singh will be give actually the online demo also with the help of the Optiwave software, and we will explain how that we have to Optiwave software. That is actually his that software is costlier, but that software will be for the student purpose also evaluation purpose. Their company also providing the platform to the students also, PG students, PhD students also. They are helping at their level. Only that is having the limitation number of days that evaluation copy give 1 week to 15 days, maximum 1 month also. Can give the request 2 months also, they will give. This is the most common fiber optic networks and communication networks. That is mesh network, ring network. Various topology we can form with the help of this optical networking. And how we have to modeling of that network for the transmitter and receiver and with the help of the backbone. That everything that will be the will cover and that will be give the information by the Amandeep Singh, and he has the knowledge in that field. They are continuously working in that the optical field. Therefore, to thanks to him also to accepting our request, and he has quickly accepted our invitation and given the valuable time for to conduct today's webinar. And I had to thanks to him, and congratulations to all the ISEP core team members and our faculty coordinator, ISEP coordinator, our Dr. Raju also, and principal sir also, and all the members and faculty members of EFTC. Thank you very much. Over to you, Harshal.
Thank you so much, sir, for your kind words. Our today's eminent speaker is Mr. Amandeep Singh, sir. Mr. Amandeep Singh, sir, comes with 10 plus years of total experience in electronics and photonics design automation domain. In his current role with HR Universal System, he is committed for his contribution to the technical aspects of photonic design and simulation with latest technologies and providing his specialization services as a turnkey solution with nearly all IITs, NITs, Indian defense, space and research organizations in India in the field of photonics up to the component level. Sir, with his team, is engaged with various projects for design, simulation, and optimization of components, links, systems, and networks for the dynamically growing fields in the photonics nanotechnology, optoelectronics, optical networks, and other photonic applications for ISRO, SAC Ahmedabad, LASTEC Delhi, LRD Bangalore, ADA Bangalore, etc. Prior to that, Sir has worked with Gigasoft India, New Delhi, the photonics division as a assistant manager, managing the application-oriented services related to electronics and photonics design automation for India and SAARC region. In his other past role, Sir has worked with organizations like AMD Limited, New Delhi, as an application engineer for technical support on design and simulations. Sir also holds Cadence, Optiwave, RHCE, RHCI, and RHSS certificates. Now, without any further ado, I would like to request Mr. Amandeep Singh, sir, to start over the webinar. Over to you, sir.
Thank you so much, Harsh, and especially a big thanks to Dr. Babban along with other faculty and administrative members. So, as per the name of the webinar, that is modeling of optical networks. So, we will discuss how we can design various aspects, or you can say the applications using Optiwave modules, so that you can enhance your simulation, or you can say the project level, using or utilizing such kind of simulation tools. So, without further delay, I think we should start with the presentation first, and then we will discuss the features of the OptiSystem software, where you can drag and drop the components and you can see the simulations. Let me share the screen.
Kunal? Yeah.
So let us start. So first of all, related to Optiwave designing. So Optiwave has a brief history, and it started in 1994 and later on shifted to Ontario. So they say that we are the world leader of simulation and design softwares. Basically, if we talk about photonics, then it comprises of everything related to the speed of light, whether the components or their features, or you can say collectively, you can say the transmitters, channels, and at last receivers. So whatever the components you require related to this optical communication network or for photonic components. So you need to be precise related to the transmission, channel and reception. So let us go ahead and see how we can do the same simulation using various modules. But today's focus will be purely on Opti system, that is for optical communication system design tool. So first of all, system level, if we talk about Opti system is used for optical communication system and amplifier designing. It means you have the ready-made components with you. You can change the parameters, connect the components with each other in the form of transmission, channel, and receiver, and then you can simulate it. Next module is OptiSpice. Basically, this is a combination of opto means optical components as well as electrical components. So that was the first optoelectronic circuit design tool where you can utilize the set of, or you can say the combination of the optoelectronic components, do the simulation, and if it is feasible for you, if it is okay for you, that results are satisfied, you can use the same designed component in Opti system as well. Means you can interface the OptiSpice module in Opti system, and there you can utilize your time, you can calculate or do the analysis how your designed optoelectronic component is behaving inside a optical communication layer network. So this is about OptiSpice. So the combination of both the modules, we call it as a system level designing. Now, if we look inside the components we are using here, so if you want to shift your application or field or for the students of final year, so they can go for this material designing or material management designing, because in India right now it is a boom. For example, if I talk about RRCAT Indore, so they are working on gratings. If I talk about IIT Dhanbad, that was earlier ISM Dhanbad, so they are purely working on the various kinds of materials. So they are using these component level modules as well. For example, if Opti BPM, like you want to utilize this, you can design your own optical couplers, your modulators, power splitter, power combiners, means the components available in the market or the components with which you want to utilize inside one of the flowchart of transmitter, channel or a receiver. So all are comprises of a material based components. So in that case, we have waveguides, various kinds of waveguides inside this OptiBPM material library, along with the various kinds of material like silver, gold, and the combination of various other like silver nitride or like you can say for glass basically silicon nitride, silicon germanium. There are so many materials available in the material library, so you can commonly use it in BPM along with FDDT. So FDDT is basically finite difference time domain method where it utilizes Maxwell equations to analyze or do the synthesis of various waveguides based on their material properties. So here the difference is BPM is for beam propagation method, which is for you can say the passive components you can design, and FDDT you can utilize this method to reach up to nano level. Means for example nano silicon wires. If you want to simulate that, you can do it. If you want to simulate a nano particle of a gold, that is also possible. So again, depending upon the material and the calculations of various theorems like Lorentz-Drude's theorems. So these are some of the theorems which are associated with Maxwell's, and then finite difference time domain method is utilized for the simulation. And last is Optimode related to the waveguide designing. So Optimode runs at the back end, whereas it also used for model analysis. Model analysis means, for example, if you want to do the analysis of a nano fiber structure. So you have all the methods available inside OptiMode and you can utilize it. So there are a lot of like faculty members around this Maharashtra, particularly in Mumbai. They are utilizing these component level designing tools also. They have procured it and extensively working along with association of various DRDOs. The very nearest research center, like where you can go and also see the practical implementation, is DIAT Pune. So they are extensively using Optiwave modules, and parallelly they are using this hardware simulations like simultaneously, because it is very important in research. Along with simulation, you should have your exact results using various hardware equipment. So you can visit that area as well. Then the next module is OptiFiber. So OptiFiber is purely based upon the designing or customization of a optical fiber. Means if you have your own idea, or if you have your own research related to fiber and you want to design your own fiber, so you can choose the materials from OptiFiber library. You can dope them, you can co-dope them, you can use a host material in the core or cladding, and rest you can design the whole fiber. You can extract the results, and even the same results can be utilized inside Opti system. Means you design your fiber here, and if you want to use the profile of this fiber in Opti system layout, you can interface it with the Opti system as well. So that is the beauty of this interface network designing. Then the last is optic grading. So optic grading, from the name itself, it is for fiber bragg ratings. Means you can design your own fiber bragg ratings, or even the photonic sensors you can design using this. So in India, only RRCAT Indore is the one. Those people, like, they are fabricating gratings, and they are utilizing this optic grating as well for their research work. So this is about the component level. Then at last, our new product, that is Opti Instrument. So Opti Instrument is a tool which allows you to interface your communication instruments. Means, for example, if you have an optical spectrum analyzer, or you can say any source generation module you have, or oscilloscope, like the instruments which display the results. So you can interface Opti instrument with that equipment. You can fetch the data using ASCII codes, and the same data can be utilized inside Opti system as well. Means if you have real-time values with you, you can check that real-time values in your communication network that is inside Opti system. So this tool is in huge demand in India, basically related to defense as well as space. So they are extensively utilizing all these tools. Now we will jump to some basic, like of this Optiwave products, where you can download the evaluation, you can sign in, you can download the evaluation. That are 30 days evaluations are available for all the modules, and you can start working. You can at least analyze as per your requirement, and you can extract the results. So further, so after the installation or downloading, you can go to the documentation as well. There are installed folders. And now coming to the optical communication, the main part we need to discuss. So as everyone knows, related to optical communication, so it is also known as optical telecommunication, and is a communication at a distance using light to carry information. So it can be performed visually or by using electronic devices. So this is a common definition of optical communication. So you can explain it in a number of ways, and the main fundamental is the speed of light, right? From the flow chart below, you can see how your signal is transmitted through a transmitter. Then a communication channel is there, so that you can pass on your message. It acts as a medium, and at last we have a receiver. where we can check out the various factors of optical communication network, like Q factor, BER, or even you can check OSNR, optical signal to noise ratio. So these are some of the important factors or parameters which are basically taken care during the fabrication of your whole system designing. Now, moving forward, some of the applications. So advanced modulation techniques you can utilize in this OptiSystem platform. New radio front hall, optical amplifiers, then microwave photonics, the most important QKD, the quantum key distribution. So let me tell you regarding QKD, we can discuss further related to this also. QKD is a very secure method. It is a cryptographic method where you can transmit your data in encrypted way so that it cannot be hacked in between, and once it reach the receiver, so photon by photon the receiver may count using a counter, and they can analyze whether this the message sent was disturbed or not. So it is the safest method with a lightning speed using OptiSystem as well, because QKD is one of the application and there are a lot of branches. Right now, if I talk about the real development related to QKD in India is in DIIT Pune and SAG, that is a DRDO at Delhi, LRDE Bangalore, as well as DEBL. DEBL is also a DRDO and they are working on this QKD as well in Bangalore. So this application is now a boom along with FSO, that is free space optics. So the combination of that is like something you will be like very happy to achieve that in case you are working on these topics. So like in the research factor in the field of telecommunication or communication in India or across other countries like Japan, Australia, UK, Canada, Russia, Israel. So they are at the medium level, and like research is not the end. And side by side, you can also think for this application. Now, next is sensors. So we have a library related to sensors here like OTDR, FBG, PCF means photonic crystal fibers for biosensing. OTDR, everybody knows about OTDR, FBGs are fiber Bragg rating. So OTDR basically, it is a standalone component available in OptiSystem. You can feed your parameters and analyze how your various factors, splicing or conjunctions or various other results you can achieve using this OTDR component. Then FPGs, whether you can use the ideal FPG available or you can again interface your designed component in OptiGridding, like FPG if you have designed in this OptiGridding, you can interface it in OptiSystem as well. So these are some of the features. Then we have optical wireless communication like Li-Fi, VLC, satellite. Then FS is also there. That is a part. That is a huge application. Free space optics. Then we have special division multiplexing like few mode, multi-mode fibers, then single mode and multi-mode along with multi-core fibers. So these are some of the combination of special division multiplexing. Then related to the components. See, this is the theoretical part basically, and we have some graphics here related to the visualizations. And I will explain you some of the components using the platform as well. So first of all, let us go through with this PPT, and then we will move on to the simulation platform. The light sources, for example, continuous wave, then LED, VCSEL, DFB, Fabry Parrot, white light sources, and so on. So we have light sources for a utility you require. Then optical modulators like Mach Zehnder modulator with dual drive, single drive, PAM, PM, AM, FM. Then bit sequences, like you need to use these sequences when you are doing some digital analysis of optical communication components, right? So, for example, pseudo-random bit sequence generator, user-defined and compliance test patterns. So these are some of the bit sequences. Then optical fibers, single mode, multi-mode, multi-core, and so on. So I will give you a brief of the library of optic system. Then electrical modulators, OFDM, quadrature modulator. Then some various other formats like RZ, NRZ, CSRZ, and so on. Then the combination again for optoelectronics like ring resonators, laser drivers, switches, optical interconnectors. So these are some of the optoelectronic circuits available, or you can design your own idea inside OptiSpice and drag and drop the component here in OptiSystem. So some extended list, then signal processing related to DSP, equalizers, recovery data, clock recovery. So related to signal processing, we have some components, and FEC and bit mapping, detectors, pin or APD, optical amplifiers. So we have optical amplifiers standalone as well as the combination, or you can say the co-doped fibers amplifiers, then electrical amplifiers, passive modules. The same you can use as it is as a component, or otherwise you have an option to design the same in OptiBPM. You can feed your own parameters, design your own component, and use it inside OptiSystem. Opti-mode applications like fiber amplifiers, mode generators. Then optical channels we have fiber, Li-Fi, satellite, FSO, VLC. Visualizers, optical, electrical, binary, M-array. See, in terms of optical communications or photonic designing, there are 4 types of signals that can be utilized using Optiwave modules, that are optical signals, electrical signals, binary signals, as well as M-array signals. So you can utilize these signals, and after designing, wherever you feel that you need to fetch the results graphically, so you can attach the visualizers available in the library. So you can use these components in unidirectional and bidirectional along with single and dual polarization. So some of the applications. Now the students, I request you to please be attentive, because these are the applications you may get interested after my lecture, or like you can go for some field type of analysis, means you can talk to your faculty members, those who are into research, and you can take the guidance of their application methodology, and further you can go ahead with the simulation. So regarding the simulation, I already shown you that how you can install it, how you can download it, and in case you feel any difficulty, you can contact us or Dr. Rinde as well for any of these queries. Now, you can design optical communication system, a whole design which actually comprises of systems basically related to the transmission, channels, as well as receivers. Then you can go ahead with some other applications inside this, like DWDM, then CATV, TDM or WDM network designs, passive optical networks, advanced modulation schemes, sonnet designs, then using optical amplifiers. If you want to design this particularly, so you can utilize EDFA, erbium doped fiber amplifiers, and Raman amplifiers, semiconductor optical amplifiers, and different rare earth doped fiber amplifiers. So these are some of the applications, and in continuation, we have some multi-mode transmission systems. Along with that, in case you want to like use a third party tools, for example MATLAB simulations, if you have any idea, any function readily available with you, or you want to design in MATLAB, so you can design it get that .m file and interface it in OptiSystem at a location where you want your function to perform, whether it is a transmitter, channel, or a receiver. According to the function of a layout, you can design a MATLAB simulation and you can interface it in OptiSystem. Similarly, we have C++ code simulation and Python simulations as well. So those who are well versed with Python, C++, or MATLAB, they can use any module to design your own function, own component, and interface it in OptiSystem. Then, in case you want to design some sensors, you can take the help of various other modules in Optiwave like OptiGrading, OptiBPM, OptiFDD, OptiFiber as well. So you can correlatively, or you can say collectively, you can use these modules to design your sensors. Then signal processing, free space optics, radio over fiber systems, microwave and RF optical systems. See, if I talk about LRD specifically, because like being an Indian, it is good to know, and we should be proud that our defense people are working on like the applications related to the targeting of the missiles, or from, you can say, the conversion of radar signals to the optical signals. So LRD is one of the DRDOs, those who are efficiently utilizing these platforms for various kind of such applications. Now the global parameters. So this is very important, very important, because it is not necessary that just drawing the component or dragging the component inside a layout and giving the parameters, you can simulate the efficient result. Whereas as a part, or you can say as a backbone of the whole communication channel, you should know that at what bit rate you want to work. For example, 100 Mbps, 500 Mbps, 1 Gbps, or even terabits per second. So it depends upon you at what level you want to simulate your whole communication network. So this is a theoretical part, like bit rates, symbol rates, bit sequence length, number of samples per bit. Then if we talk about the step size calculation, you can calculate, or you can see the layout box when once you start working using OptiSystem. You can get to know how you can handle the parameters related to these frequency windows, step size, bit rate, bit sequence, and number of samples. So I can share this PPT with the faculty members or students as well. So I can forward this to Dr. Rinde, and in case anybody is interested in optical communication applications or your projects, so this will be helpful. Okay, moving forward. So this is just an example to understand. Rest we will discuss it using simulation platform. So if the bitrate is 10 Gbps, the sequence length is 256 bits, and the number of samples per bit is 128. Then the number of samples will be equal to sequence length into samples per bit rate. So if you can analyze or see this, so 10 exponential to 9, exponential to 9 means 10 Gbps, or equivalent to, you can say, 256 into 1 by 10 Gbps is equal to 25.6 nanoseconds. So similarly, you can decide your own time window. I will show you how you can design a very simple system where you can check in how much seconds you are getting the result. So we will discuss it. Then sample rate, similarly you can go through the sample rate as well. The number of samples per bit parameter is used to fine tune the resolution of this simulation. For example, if the number of samples per bit are not up to the mark, you may not able to see the fine-tuned resolution of your conclusion. Means at the receiver side, like once you are like over with the project and you have simulated it, so the simulation results or the graphical view will be fine tuned when you particularly focus on the number of samples per bit. So the long bit sequences can be used for signal statistical metrics such as eye diagrams or bit error rates. So this is the most important part in the field of optical communication system designing, because it depends upon the photonic light, or you can say the speed of light, and the data you are incorporating or modulating and passing through a channel and getting it on a receiver, so that you can get eye diagrams and BERs. So that will make a efficient layout where your eye diagrams or BERs are up to the mark. So the short bit sequences can be used to study signal optical effects. I repeat it again, short bit sequences can be used to study signal optical effects such as attenuation, or you can say the dispersion. So this is another important factor related to the bit sequences and used to study the signal optical effects. So at last, this is the GUI, or you can see the platform of Opti system, where at left hand side you can see the optical component library, and at right hand side a place where you can drag and drop the components and do the simulation. Now, further to this, we need to focus on how to make a layout. So this is just a basic example, like steps to build a project and calculate it, then setting global parameters, selecting components and visualizers. Basically this is a flow chart. Then selecting components parameters, connecting components and visualizers, then calculate it. So these are the steps for the designing of any optical communication link. Like setting up global parameters are important because you need to define the bit rates. Then selecting the components are important because the components will decide your functionality or idea behind that project. And the visualizers will give you an enhanced idea in a graphical way so that you can understand at what level like after the calculation, we do necessary analysis like monitoring, analyze it, generate the report, store the project along with data and graphs. So data is important because, for example, if you want to publish a paper, so you need graphical as well as the statical data, or in coordinating matter data, where you can explain it efficiently. So in component library at left hand side we have component search as well. So you can search the component. If you know the component, just type it and search it in the library. So you can change the parameters to normal or script mode or sweep mode. Means, for example, if you want to sweep length of a fiber, or if you want to analyze how you what are the results when you change the length of a fiber from 10 kilometers to 100 or n number of kilometers, right? So at each 10 kilometer steps or 50 kilometer steps, or whatever the location you want to see, you need to feed that, you need to feed the parameters linearly, logarithmically, or as per your customized parameters. You can feed it and see the results once the calculation is over, like how your fiber is like behaving inside optical communication environment once the length is increased or decreased. So accordingly, you can generate various kind of graphs like Q factor versus length of fiber, BER versus length of fiber, then some time histograms, or you can say some apodization, or you can say the photo effects of a pin diode with respect to the average photocurrent. So these are some of the comparisons. You can draw a chart, you can collect the parameters in graphical as well as in coordinate method. The coordinate method means x, y, or z values. So similarly, if we talk about script means if you know the VB scripting, you have the functions available in VB scripting. Just start programming it, and you can script your own parameter. It depends upon you how you want your parameter to reach. Then normal means it is by default value, means the component comes, every components in Opti system or any other tool comes with a by default value, and these values are normal, means as per the fabricated equipment, or you can say the fabricated specification sheets. So accordingly you can sweep the wavelength. So this is one of the example I have taken here, and we have already discussed about the length sweep of a fiber. So any parameter of any component you can sweep. So this is how you can. Yes, sir. Yeah, please. Yes, definitely we can do that, but we need to be specific regarding the components that are being utilized in your whole projection. Basically, what are the components you require during the transmission design? You do using this channel as well as the receiver. And once it is over, you can also move it for AI. So AI basically now it is also a boom, AI along with QKD, like it is one of the example. But yes, definitely you can do that. Or otherwise, at last we, like every module or every other tool available in the market provide third party interface such as MATLAB, C++, and Python. So you can utilize these tools as well to design your own function for your this particular project you are talking about. So I think it's better you can download the evaluation, and you can design it and try to design it. And in case you feel any query, you can write down to us. I do hope this is clear. So moving forward. So this was for one of the example for sweeping. Then report generation. So after the calculations, you have a space here, a platform here where you can drag and drop the results here from your left window. That is basically a project browser. So whatever the combinations you want to make here, whatever the combination means, the parameters and their comparison with the other end results. For example, BER, or you can say the Q factor versus total power consumed. So these are some of the main factors across this optical communication side at a receiver end or in between if you have various applications like WDM or DWDM, FSO, and so on. Reporting is fine. Then you can save the figures, means for example the spectrum analyzer. At this point you can click it, you can see it, and then go to the toggle at left hand side, and you can copy this image and you can paste it in your Word file or any other platform where the availability of image copying is supported. Then there are some general notes to how to basically utilize it, because see, until or unless you utilize your time on software, so these all like will be of no use. So these are just the step by step algorithm, or you can say the step by step flow chart, how you can go through and utilize this design, and how you can export it to various other formats as well. So the project's components parameters can be stored in order to check or review them at any time. For example, you have made a huge project, and like it will be difficult for you to click on every component and record the parameters you have utilized in your whole project. So here we have a feature where you can export the whole project in Excel format, where you can find the parameters you have used for every component, that you will be available, like you can get it available using export format there. I can show you using that platform once we are at simulation. Then all optical components output data is presented in frequency domain, while the electrical components output is presented in the time domain. So you should understand the concept first, because if you want to work on the frequency domain, you should need to understand the optical components and their characteristics. And similarly, if you want to work on the time domain part, then you need to understand the electrical components characteristics. Then MATLAB component enables setting time or frequency domain for the output sample data. So this is one of the beauty. So you can utilize this component for setting the time and frequency domain. Now, it is important slide, because we are on the verge of releasing Opti system, and here is the list of the new components that we will have in this system. IETE-SF weather condition. So this is a new component. I do hope most of you have already utilized this Opti system tool, whether evaluation or licensed one. But the upcoming module will have these new components, and these will be the important factors for free space optics. For example, related to FSO weather condition. So the new component is used to calculate the attenuation of the FSO channel at any wavelength under different weather conditions like clear, haze, fog, rain, snow, and different cloud types. So earlier in 19 version, in which like I will be explaining you, so that consists of a FSO component, and accordingly, as per the attenuation, like we need to define, we presume that this will be the condition, like fog condition, rain condition, or underwater condition. Accordingly, we set up the 19 version component. But in 20th, we will have a full GUI where we can set the parameters according to the different weather conditions. That will be a plus point. Then another component is user defined M array sequence generator. So that is a newly added. It is used to allow loading standard M array sequence used in the TDECQ analyzer, means transmitter dispersion eye closure quaternary, right? So until or unless you use this, you will not understand the basic standard or sequence of M array. So M array, visually we can see it using TDEQC analyzer. So that will be in upcoming 20. This visualizer is used to quantify the performance of PAM4 systems through their PAM4 eye diagram. So we will discuss it further. Then related to this particular analyzer, that is transmitter dispersion eye closure quaternary, this analyzer or visualizer is used to analyze the eye diagram PAM4 transmission system. Then optical to electrical converter. So this component can be used to convert the optical field directly as electrical field, and it could be related to your complex, real, only signal or power, depending upon the field you are working on. Next is electrical signal clipper. So a common electrical signal clipper, you can get it there. Then electrical transfer function visualizer, like that is ETF. So you can utilize this in our upcoming 20 version, and we do hope it will be released before March, and let us see. Then this is the overview. Overview means the GUI of OptiSystem 20. You can see here underwater or the clear ocean attenuation type. So in this box, you can see how you can set the parameters like absorption coefficient, scattering coefficient, transmitter settings, receiver settings. So accordingly, you can select the salinity, means if you are working for underwater communication system, then salinity you can define and temperature you can define. So in the earlier version, we are not having this, but this is incorporated in our new release. This will be in our new release. So thank you for your patience, I can say that. And in case you have any query, you can contact us at info. And by the time we will talk about some of the features using GUI method, that is your simulation platform. So from here you can click a new sheet, just assume it as a breadboard, a table which is available for you to place the components, connect these components, and just give a boost through a source, through a transmitter. And at a receiver side, you can design a very simple signal, first of all, because you need to understand the layout parameters. So this is the one I was talking about related to the bit rate. So by default, this is 10 Gbps, 10 exponential to 9 bit per second. That is 10 Gbps. And accordingly, you can see here your time window will behave. Means related to this bit rate, your time window will be 0.1024 exponential to -6 seconds. And the sample rate will automatically will get shifted. Then sequence length, you need to define the sequence length here, and the by default value is 1024. Then samples per bit, so right now it is 32. It depends upon your project whether you want to use 8-bit, 16-bit, 32, 64, and so on. Now first of all, let me tell you how this time window changes. For example, instead of this 10 Gbps, I am using only 1024 bits. Then your time window will change to 1 second. If I am using only 1024 bits, then your time window will change to 1 second. And because, let me tell you, now if I change the sequence length, for example, 512, it will be 0.5 second, means half second. Similarly, 512 bit rate, so this will be 1 second, and 1024, 2 seconds of a time window. So this is just an example, right? Otherwise, you must be like if you are a beginner, you can start working using some 100 Mbps, then you can change it to 500, then 1 Gbps, then 5 Gbps, 10 Gbps, and so on. According to your understanding, you can move ahead related to these parameters. So first of all, let it be with the 2 seconds. Let us start with the 2 seconds only, first of all. And one thing I forgot to mention you. So we are using a reference wavelength of 193.1 terahertz, or let it be in terahertz, 193.1. So this will be the reference of the whole layout. So you need to mention it. Now let us use a optical laser, then bit sequence. So we have pseudo random bit sequence generator or user defined. So the difference is only that in user defined, you can define your own bit sequence, 0, 1, 0, 1, 1, and so on. So you can define your own bit sequence, or otherwise, if you don't want to use this, you can use this one, pseudo random bit sequence generator. So randomly it will generate the bits, and it will take the bit rate of your layout, means the bit rate you have set up at this section. For example, this is 512 bits per second. So that bits will be utilized here. So randomly it will generate the bits. Okay, let me delete this one. Then, so these are the bits. So you can double click on the port and see this is a binary signal and it is a bit sequence. Now I need some pulses. So let it be electrical. NRZ. So NRZ pulse generator, from the name itself, non-return to zero, you can understand. Now you can change the parameters of this NRZ pulse generator. Means, for example, you want to change the shape, you want to change the value of the shape, like exponential, Gaussian, linear, or sine. So you can choose the shape accordingly. So like exponential is by default, and other parameters are available here. You can change them as well. By the time I'm using by default value. Now we need a modulator. Mack and Zender. So these two scientists, they have developed this modulator. This is fine. So these are some of the steps you need to follow, and please be precise while you design your layout. Your layout should look beautiful as well, because if every component is at their particular place, it will be easy to read and understand it. Now this transmission portion is over. We have done with the transmitter. What you are transmitting, let me tell you what you are transmitting. This is optical signal. Accordingly, I can use a visualizer. Optical. This is optical spectrum across modulator, across component, and this is being an electrical signal. This is an electrical signal. So here you can use oscilloscope visualizer, RF spectrum analyzer, and various other, because this is not a good idea to attach BER analyzer here right now, because this is not conceptually right. We will use it later on. Just keep it aside or delete it. We will use it later on. Now, if I just simulate this only transmission portion, you can get this signal, and this signal is for 0 to 2 seconds. 0 to 2 seconds. So this is your oscilloscope visualizer, and in case you want to see your signal at 1 second, you need to unclick this automatic range, start with 0, end with 1. So this signal is at 1 second. So 0 to 200 millisecond, 400, 600, 800, and then 1. So this is the signal, and this is the RF spectrum, and for the resolution of some 10 megahertz, in case you want to analyze it or want to see the resolution bandwidth at such point, you can use the resolution one. So you can see this line, the constant one, or at this section, power versus frequency, this is constant. And this is the pure signal form. This is the noise. Noise at minus 100 means this is constant at minus 100 power, minus 100 dBm. Just close it. Then optical spectrum. So first of all, we can see the optical spectrum here. Optical spectrum of what? Of this laser source. The frequency, like by default frequency is 193.1 terahertz. Power is 0 dBm. Means it is not particularly 0, but this is 1 milliwatt. Line width 10 megahertz. So accordingly, as per your requirement of a source, you can change the frequency. Right now, if we convert into nm, so it is 1552.52. So just click this. Now you can see we have 0 spectrum. Just a minute. This is because, let me tell you, so this is the sample signal at resolution 0.01, whereas you can see this 1.5525 microns. So this is the wavelength. Let me change some parameters. Let it be a generic 1550. So as I have shown you, like 1 second to 2 second time window. So now this time window will get changed to 0.1024. So this is in dBm. So now you can see the spectrum, how it is designed here, power versus wavelength. Similarly, if I double click on this, so that is the spectrum of after modulation. So you can see the parameters, and you can also look into the data. Data means X and Y values. So these are X and Y values, your sampled signal spectrum. You can copy it, you can export this curve to a text file, and later on you can also export this to Excel file also. So I think you understood how you can utilize the components available in the system. Now we are done with the transmission. We need a channel now. Let it be a wired channel, that is using a optical fiber. So the by default length is 50 kilometers. After this, we can use the receiver, photo detectors. You can choose any receiver. Let it be pin photodiode. This is done. Now, this is a very small project. Project means you can analyze or do the synthesis of a communication system whose like transmitter is 50 kilometers far than a receiver, and the medium is optical fiber. So if I double click on this optical fiber, so the reference wavelength is 1550 nm. You can change this, but whereas I am using this 1550 only, and now the length of the optical fiber you can change it accordingly as per your wish. Attenuation effect, attenuation data type, then the most important part, that is dispersion. So this dispersion is set according to the parameters like dispersion slope, beta 2, beta 3. You can set it. Then PMD, like bi-references, you can choose it. Like you can choose this deterministic or stochastic, you can choose any one. Now differential group delay, PMD coefficient, you can change it accordingly. Then non-linearity related to numerical apertures, then graphs, and so on. So let it use this by default value 50 kilometers, and we can change it later on. Then if you talk about the pin photodiode, so this is the responsivity type. Now depending upon the photodiode or like absorption, the type of absorption you want, so you can use the material accordingly. Silicon, germanium, InGas, or if you want to define your own, you can define your own responsivity here. So you can include the noise like thermal noise or short noise depending upon your requirement. Then frequency response, you can change the junction capacitance, modulation bandwidth, and downsampling. So there are some parameters related to this pin photodiode. This is generic pin photodiode. In case you have any available in your lab, you can take the specification sheet as a reference, and you can start changing the parameters according to that. So you can also correlate. Okay, so this is done. So we are done with the design of a simple layout, whereas we need to attach a most important visualizer, that is BER analyzer. So that is the one which will give you behind the data collection. So let me connect this first of all, and we will discuss why I am connecting these to these ports. Okay. So first of all, this BER, what is this BER analyzer? Right click, go to the component help. So this visualizer allows the user to calculate and display the bit error rate of an electrical signal automatically. It can estimate the BER using different algorithms such as Gaussian, chi-square, and derived different matrices from the eye diagram, such as Q factor, eye opening, eye closure, extinction ratio, eye height, jitter, etc. So these are the important factors. So this is the important definition in terms to understand the working of BER. It can also take in account forward error correction, that is FEC, plot BER patterns, and estimate system penalties and margins. Why you need a simulation software? You need a simulation software to estimate system penalties and margins before you actually deploy the equipments on the roads or the locations, right? So if you want to establish an optical fiber communication network, so that is a huge branch. You can distribute it using various applications like WDM and all, but you need to understand, or you need to analyze it, the estimate of the penalties or bit error rates. Accordingly, you can do further research and development, that is known as R&D, right? So playing with the parameters of each and every component and getting a best estimate at the end will help you out to make a efficient optical communication network. So these are some of the parts. Let me come back to the BER analyzer. So these are the three ports for this BER. The last port is for electrical signal, that is at the receiver section. So it requires electrical signal of a receiver. Then the middle one, it also requires the electrical signal, but from the transmitter side. You can see this blue connection here. So the blue dotted lines will show you the electrical connection, whereas this red dotted line at the first port will give you a binary signal. So this BER analyzer will compare the result of a transmitter with respect to the received result. Now, let me simulate this. I have not used any other component here. So this is very simple one. Hope we get some conclusion here for 50 kilometers of a communication system. So you are getting a Q factor. This is I diagram. This is not efficient at all. Let me tell you why. Now this is the framework of your project. Now you can start your R&D here. First of all, start with the source, as it is having a 0 power. Let me use 5 dBm. Change it to 1550 because we are using 1550 wavelength of optical fiber. So that should be similar. And this is the reference wavelength we already have set up, 1550. Okay. So the power we have increased to 5 dBm. Now I think we need a filter as well that will fine tune this. Let it be Bessel or Gaussian, any filter you can use that. And like those who want to save their money, they are not using any amplifiers, right? But as per the methodology, across optical fibers, you can use the amplifiers. You should use optical amplifiers. For example, inside this we have optical amplifier, this one. Or first of all, let it be like EDFA only. We will compare the result afterwards. So erbium doped fiber amplifier. This is very common and its length is 5 meters. You can change the pumping as well. You can change the cross section, numerical, polarization. So anything you want to change, you can change in this. So you can change the length. Okay, let it be a by default. Now I think it will make sense. And also let me increase some samples per bit. Let it be 64. NBVS is fine. Rest is fine. Now simulate this. Simulated. Oh, we are not getting anything. First of all, let me use this as it is. It is wrong. I have forgot to change the units. 1550. First of all, without any amplifier. Yes. So this is the perfect Q factor we are getting. And this is minimum bit error rate, 10.7114. This is Q factor, this is minimum bit error rate, threshold, this is height, and if you want to see the I diagram, this is I diagram with some more ISI, inter-signal interference. But let me fine tune this. So this is 10.7. Let us include this one as well. Let us see if we get something. So again, it's 10.3, not a better one. And if I use this generic optical amplifier with gain control and 20 dB gain, you can change the operation mode to gain control, to power control, to saturation, or signal power control. Whatever you feel you require in the project, you can utilize this. Simulate it. We have 10.6, nothing has been changed. So now this is a pure R&D, and instead of this one, first of all, let me see. This is fine. Let me increase this to 10 dBm. 1550 is fine. And let us simulate this. So this is at 10 Gbps 9.8, and in case I increase the bit rate, let us see. It's 3.44 because the bit rate has been increased. And in case we use 5 Gbps only, so it's 24.80, it increases. So this all depends upon the components you are using here. For example, in case instead of this fiber, instead of this wired channel, if you want to use OWC channel, this OWC channel is basically utilized to simulate or analyze the communication between satellites, that is for inter-satellite communication, from ground to satellite and satellite to ground communication, or from planet to planet communication, because the range is huge. Just delete this, as we are working 1550 nm environment. Range is by default 200. So rest are the parameters like transmitter aperture diameter, receiver aperture diameter. So related to the telescope or lenses, you can change the parameters accordingly for this optical wireless channel. If I simulate it right now, let us see if we get something. So your maximum Q factor is 76.88, minimum bit error rate is 0. That is perfect. So this is the Q factor. So you can enhance it a lot. It depends upon the components and the parameters and the ideas behind your mind. Like whatever the function you want to design, you can choose the parameters accordingly. So right now, instead of Bessel filter, if I use this Gaussian one, I think we may get the results, better results. Instead of 64, using 32 only, and let it be 10 Gbps only. So 64.4, perfect eye diagram without ISI, minimum bit error rate, threshold, height, and this is 0. And rest, if you want to play with the graphs, you can change or invert the colors You can change the color grade as well. So accordingly, you can copy your image to clipboard and paste it to your text file or Word file. You can export the data X and Y coordinates as well. So this communication range is 200 kilometers. And for example, if I sweep this, so similarly as we have discussed about the sweeping of the length of optical fiber or any communication channel, so we have a mode here, sweeping, and I want to see the iterations. Let it be 10 iterations. Select this linear starting from 100 to 1000 kilometers. I want to see how this communication part is 100 to 1000. Okay. Calculation is finished. So this is your result. This result is at 10th iteration, means at 1000 kilometers. Still you are getting a Q factor, which is a good part. And at various iterations, for example, at 100 kilometers, this is 119. You can change this from this toggle as well. Next sweep, 200, 300, 400, 500 kilometers, 6, then 700 kilometers, 8, 9 and 10. For 1000 kilometers, you can get this type of communication result using BER analyzer. So this is the importance of the BER analyzers. It enables the various collection of parameters you are utilizing in your communication environment. Now, if you click on this report page, you get this project browser. In case this project browser is disabled, you just need to click on this view and click on this project browser. So it is a list of the components you have utilized while designing your this layout. Now, for example, as per our earlier discussion, you can compare some of the results. For example, I am sweeping the length of this one parameters. This is the range. Just drag it and drop it as per your requirement, means at X or Y. Anywhere you can drop this accordingly. So I'm dropping it at this section X. So this is for X range 100 to, it is showing 900 here. So you can change you can see the parameters, or you can change the legend of these using the properties. For example, at X-axis, it is linear or logarithmic, decimal, exponential, engineering, scientific, let it be engineering, 100 to 900. And then again, if I use scientific, so scientific in this form, properties, X-axis, exponential, so the exponential will be in this form. Okay, so not making it much complex, so you can play around with the various axes here, and you can change the axis color, and you can use it for various ranges, minimum value to maximum value, by the time it is taking the automatic range. Next is, so we have placed the range at X-axis. Now we need to move further. Now what you want to compare this with? So let us reach to the BER analyzer, and under BER analyzer you can see the graphs here. Graph means the graph folder. So in this graph folder, so these are the standalone graphs. You double click it and get the graphs here. But in case you want to compare this, or you want to see the analysis, for example, minimum bit error rate across various levels of this this communication range, 100 to 1000. So this is the BER level. At 900 it jumps, means up to 900 our signal strength, or you can say the calculations are good. Similarly, if I want to see the Q factor, so this is the maximum Q factor across this communication with respect to range 100 to 1000. So your Q factor is like going like this along this curve. To see the parameters, export the data, you can see across the kilometer values. At 100 it is this, at 1000 it is this. So these are some of the ways you can compare it utilizing this Opti2D graph. Apart from that, you can use these graphs as well, like amplitude histogram, amplitude probability, then BER at measured threshold, then I amplitude. So these are the various iteration levels, means sweep iterations, the calculations we have. Then I closure and then I diagram. So now if it is a complex one, so you need to use a higher RAM, or you can say a workstation should be of a higher RAM, more than 12 GB at least. Similarly, Q factor. So these Q factor levels are at various sweep levels, means 10 sweep iterations. And similarly, we have other graphs as well. So inside a visualizer, means BER analyzer, then we have optical spectrum analyzer. So every analyzer which shows you a graph or a graphical representation will have such kind of graphs here. So these are overlapped to each other because these are the sweep iterations from 1 to level 10, means 100 kilometers to 1000 kilometers of range. Okay, I think this is fine enough. And now let me show you a quick research paper. Okay. So this is a paper presented in IEEE symposium, an efficient modeling and simulation of quantum key distribution protocols using Opti system. So the abstract, let me read you what is the main factor behind this. So in this paper we have proposed a modeling and simulation framework for quantum key distribution protocols using commercial photonic simulator Opti system. So this simulation framework emphasizes on experimental components of quantum key distribution. So we simulate BB84 operations. So this is one of the protocol with several security attack scenario and noise immune key distribution in this work. So we also investigate the efficiency of simulators in built photonic components in terms of experimental configuration. So this simulation provides a study to analyze the impact of experimental photonic components in quantum key distribution. So just overview, like basic QKD setup. If you can see this, laser optical attenuator, linear polarizer, then sections, then optical fiber, and you can see the various angles at which it is shifted using polarization meter. So we all have these all components are available in the optical component library Opti system. Then this is the BB84 protocol mechanism. Like they have designed Alice, then the channel, then Bob. So you can read this paper, you can buy this paper. Then this is BB84 protocol with Eve's techniques. for detector 1 and detector 2. And at last, let me come to the conclusion only, because we have time constraints. So most QKD simulations research is focused on protocol mechanism. So our study focuses on hardware setup based on OptiSystem. As we mentioned earlier, QKD is a combination hardware and protocol paradigm to achieve unconditional security in key distribution. So both the paradigms should be evaluated correctly to understand and study the performance of QKD protocols efficiently. Our proposed simulation framework emulates the practical experiments with slightly modified components. We can modify the parameters settings of the components and able to find the optimum value. Thus, this simulation framework reduces the implementation cost by choosing appropriate components property. So this simulation setup still needs vigorous testing and analysis. So implementation of entanglement oriented and other encoding based QKD are the challenges for the future work. So like research is never ending, and you can keep on doing that and get the efficient results. So this is only a little bit, not only a 1% of a QKD, but yes, we have the option to design such type of protocols using OptiSystem. Now, the another one, like satellite based BB8 for QKD protocol. Just a second. So this is a conference IOP, a satellite based quantum key distribution using decoy state protocol. So similarly, you can also work on this. You can search the paper and you can see this, the use of satellite for QKD, key 1, key 2, then over any medium. So you can decide your own protocols here. Then the same layout using OptiSystem. So anyway, you have the platform, start evaluating it and utilize such kind of application. And the another one is underwater FSO, role of optical wireless communication underwater. So the newer version will have something different, whereas you can utilize this 19 version as well, because this is the latest one right now. You can set up such kind of layouts, feed the parameters, get the results, get your paper published, and I think you can secure good grades in your project work if you take the help of your faculty members and do some research related to optical communication. Then some other examples of research papers. Like testing FSO WDM communication system in simulation software for different atmospheric conditions. And this is the setup. You can design it. You can find a number of papers published related to such kind of applications. And these are the results. So similarly, you can get the results using this platform. These are the eye diagrams and their amplitude versus time. I do hope the working of this OptiSystem is clear to you. So this was just a basics, and definitely we will try our level best to decide some kind of a hands-on or workshop, because the lecture itself will not fulfill the purpose and it will not give you any expertization. I recommend everyone, those who are interested in this optical communication designing, they can download this from hruniversalsystems.com or optiwave.com. So the tools are available there and you can utilize it. See how this tool can help you to get your results. Thank you so much all, and I would like to know if you have any query, or you can write down to us in case you have any query to info@hrunisys.com, and we will revert you. Dr. Babban.
Yes, Amandeep. So,
Yes, sir.
thank you very much for your enlightening of on the optical fiber, the design purpose. Avinash, yes, check that question in YouTube, and yeah, faculty has to ask the students also.
What kind of mode? Okay. Yes, you can do that, but whereas you need to be precise on the modes you will be utilizing, like LP modes, vector modes, and in which mode you want to work. So it depends upon that. Or otherwise, if you want to play with the fiber as a part of a grating or as a part of a waveguide along with the material, so you can utilize FDTD. So if you want to precisely check the spectrums of various locations of excitation level of your designed fiber, you can utilize FDDT as well. You give it a try using both the modules, and in case you feel any difficulty, we are there to help you out.
Yes, Avinash, next question. Harsh, it's audible?
Uh, yes, sir. Currently, I can't see any more questions in the chat box, sir.
Okay.
Okay, not an issue. In case the participants like have any query, they can write down to us, or they can contact you as well.
Actually, 1 minute, Amandeep, one
Yeah,
minute. One of the member from IIT Bombay, he wants to ask actually a question.
yeah, sure.
Yeah. One minute. Yes, sir. Maniji, can you ask the question? 1 minute. Is yeah.
Hello everyone.
Hello, sir.
Hello, I'm Manish Kumar from IIT Delhi. I'm doing MTech in Applied Optics,
Yeah, good afternoon, sir.
and your session was very useful for us. But I want to ask, like, you are doing in opto and electronics. You are combined these branch, right?
Yes, we are using the components of these branches, means optical as well as electrical components.
Okay.
Yes.
Okay. So generally ये होता है कि like IITs में we also having opto electronics branch and applied optics branch separately.
Yes, and care branch also, sir.
Yes.
So in your care branch, it is already the licensed version is already being used by the students here. There.
Yes.
Yeah.
But what are the opportunity for in like students for like हम अभी MTech कर रहे हैं ना, like उस sense में क्या opportunity हो सकती है हमारे इसमें?
See, sir, it all depends upon the application you have, or it all depends upon the project you are funded with, right? So, your research scholars, I think you are in touch with them also. So, in case you have any particular application, you can use this Opti system, or otherwise, I will recommend you to go with FSO or QKD applications, because if you want to test your FSO systems, we have readily available lab at DIAT. So they form a like bunch of different equipments related to FSO, and they are practically testing that along with Opti system. So one is that way, using FSO application as a technique. Another one is QKD. So in Delhi only, we have SAG lab, DRDO lab, along with SSPL, solid state.
In NPL also, I think they are also working in quantum key distribution.
But regarding the level of application, it is SAG. All the security related to defense system is purely like based on various QKD protocols, and these protocols are calls are being utilized by these DRDOs. I don't know about NPL because we have not like got any query related to this QKD from them. Whereas you can contact these DRDO people as well.
Okay. So in our IT, I think one of the project which is collaborated with the DRD also, and that topic is quantum key distribution. That
Exactly, exactly. See, if we talk about IIT, so naturally, every project will be funded by like DRDO or space even, right? So, if you talk about SAC Ahmedabad Space Application Center, so they are also working on this QKD and utilizing OptiSystem as well as OptiSpice. So you can talk to them also. They can also help you out to explore as much as possible related to these applications.
okay. And one thing, sir, like we are like 45 number of students in our branch, but
Okay.
हमें exposure ही नहीं मिलता इन चीजों का. Like हम after the completing my M.Tech and my senior also, so उनको इन चीजों का exposure नहीं मिलता है, तो उनके लिए हम क्या करें?
See, sir, being an IIT, because like we are like very transparent to communicate with the students as well. See, the IIT scenario is they have every tool. They don't have any limit related to research. Whatever the students require, they have that.
No, I'm asking after the M.Tech, if someone like connect with you and connect with the other companies, so
See,
what
it
we
all depends upon your zone. Means you want to study further, you want to pursue your PhD, or you want to go for a job. Like in the IT industry, if we talk about like Japanese companies like Fujitsu or Sony, you can talk about, or even Lenovo, like in China, or various other optoelectronic component establishing companies. They can hire such kind of employees to work on their application, right? Like for example, if I talk about myself, I was in AMD as application engineer. So we collaboratively we design various projects of these companies like Microelectronics, LG. So these all work on photonic designing, and efficiently they are using such kind of tools. I'm not talking about Optiwave only. So
okay.
like there are a lot of simulation tools available in the market, but we have 85% share in the market as a part of Optiwave. So
Okay.
this is mostly utilized tool, and definitely if you are into PhD, so this is the right tool for you. You can like write n number of applications, n number of papers, and after that there is no end. You can go for postdoc as well if you are into the education zone, if you want to go that. Otherwise industries are also available like Sterlite for optical fiber fabrication. I think you are aware of Sterlite also. So that is the
Yes, sir.
only company those who manufacture or fabricate this optical fiber. They are using OptiFiber module of OptiWave only.
Okay.
Yeah.
So can we do some designing for like cancer detection equipments using the designing software?
So, sir, that is your application, and what type of like this is a huge application, but
Because I'm asking because the optics and electronics, if we connect
exactly.
these branch, so we can optoelectronics. So optoelectronics can do many things like beyond the optics, beyond the electronics.
Exactly, you are right, sir. In that case, you can go for biosensing application. So biosensing cumulatively with the combination of OptiSystem and OptiSpice, it will help you out.
Okay.
Okay,
And
Manish
similar
sir,
for
can you?
like
Yeah.
length designing and other components.
What's the length designing in which?
Because you are like your software is Optiwave, like only designing for like fibers only. Yeah, other
No,
other.
no, no. Like for OptiWave have like it is having these modules. Let me explain you again.
Sorry to interrupt. Manish sir, you can write email na? To
Okay,
the
okay.
Amandeep. Then he will better way that reply to you on by the email also. Any
These
another participants wants to ask the question?
Yes, sir. I have a question. I
Yeah,
am
Baishal.
Vaishal Chaudhary, and I am right now in my final year study in electronics and telecommunication. So, so this is a very basic question that can we splice multi-mode fiber to a single mode fiber?
See, it all depends upon the availability of parameters in Opti system.
Okay.
Uh, if I show you this component as per your query, we have this OTDR, and in respect to this OTDR, you can double click on this, and we have the configuration of parameters, like what you basically want to do, like splicing APC to APC, and the number of splicing, the coefficient reflections. So your question is related to the fibers, but it basically depends upon the various factors like numerical aperture, fiber length. It should match that. You should match that, right?
Yes, sir.
Yeah.
So, and one more question,
Yeah.
like which wavelength is the most suitable for pumping an EDFA? Like you show the experiments, like you
I will
can.
go. I will go for 1550. That is very
Okay.
generic portion, but this your question is open ended
Okay.
because this answer depends upon the application you have. It is like according to the application, whether you are using like 1000 sorry 1000 to 2000 or 2200 nm. So it depends upon the variation, but 1550 is fine. It will give you some BER, some Q factor as well.
Okay, sir. Thank you so much, sir.
Yeah.
Anyone?
Sir, there is a question in the chat box. It is possible to design an EDFA that can amplify at 1350 nanometer of optical fiber, and which
Okay.
wavelength is most suitable for pumping an EDFA?
uh, okay, let me show you that EDFA itself here. See, this is pumping, and you can pump it until or unless you get something. But here 980 nm. This is the standard value for forward pumping and backward pumping, depending upon the wavelength you require. Again, it all depends upon the nature of the project you are working on. Otherwise, you can utilize this standalone component having 980 as a forward and backward pumping.
Okay, sir. Thank you so much, sir, for this wonderful webinar. Now the platform is open for question and answer session. If anybody has any queries, they can put their question in the chat box below, and one of our coordinators will read the question for our speaker.
Manish also. Manish, you have to mute yourself. Yeah, already we have taken the question, Harsh. It's I think okay that they can write the email. Okay.
Okay,
Finally
sir.
take. Yeah, you have to start vote of thanks.
Yes, sir. A warm good afternoon to one and all. On behalf of Department of Electronics and Telecommunication of Excelsior Education Societies, KC College of Engineering and Management Studies and Research. With great respect and honor, we would like to take this opportunity to convey our sincere thanks to our enterprising and efficient Managing Director, Dr. Sai Kiran Khanna sir, for his special support. Special thanks and gratitude to our Principal, Dr. Vilas Nitnore sir, and the HOD of Electronics and Telecommunication Department, Dr. Rajiv Iyer sir, IETE-SF KCCEMSR convener Dr. Baban Yurinde sir for encouragement and support. I thank all the participants for gracing your crucial work and attending this webinar. Thank you so much for your cooperation. I also extend thanks to all the professors and other students for attending this webinar. We appreciate your support. Special thanks and deep gratitude to our eminent speaker, Mr. Amandeep Singh sir. Thank you so much sir for taking out your valuable time and sharing your valuables in front of us. I specifically thank the people who have been the backbone of the event, IETE-SF Vice Chairman and the Student Event Head, Avinash Rajak, our technical arrangement team under the guidance of Kunal Parkar, Creative Head Ananya Shetty and all the IETE-SF core members for organizing and making this event a great success. We would also like to inform you or request you all to take the part in many such amazing webinar and activities we will be coming up with. Thank you all for being us with. It was a great having you all here. Have a great day ahead. Take care and stay safe. The feedback link is been shared in the YouTube live chat in the session. All are requested to fill the feedback form to receive the participation e-certificate. Thank you.
Thank you, Amandeep Singh, sir.
Thank you very
so
much. Thank you all.
Thank you
Thank you
very
so
much.
much.
Yeah, thank you very much.